I'm a fan of this. Theoretically, what would the next question be?
Evaluate it?
Evaluate it, right? What's the problem at this point?
My calculator's out of batteries.
My calculator is out of batteries. And why is that problem? Why is that a problem at this point?
I can't do that by hand.
Yeah, you can't do that by hand. Do you have any good way of doing that by hand? I'm just asking you, is there any good way of doing that by hand?
I know.
If there were some X's out front, like what happens if there was like an X floating out here and out here? Would that be a lot? Oh, you saw all of a sudden it's really doable. But as it stands right now, is that doable? No. This is exactly the type of question they could ask you on like the BC Calculus exam on the calculator section. Like, write the integral. Evaluate the integral with your calculator. There is no nice way to do this using any techniques that you know right now. But how would you do that normally? You go, oh, they're circles, and you do pi r squared and half of them, right? You circle with radius 1, circle with radius 2, and then you'd be done.
Is there an easy way to do that?
No. Nope.
Wait, is
Those-
it really called a polar
Yeah, that's
rectangle?
called a polar rectangle. What's the polar rectangle?
So awesome.
R goes from, what is R between?
1,
1 to 2, and theta is between
0 to pi.
0 to pi. It's a polar rectangle. Yeah, it's a polar rectangle. Absolutely. Absolutely. Pi r squared. So that's the whole circle, and they're going to multiply it by what?
Theta.
Theta's in radians over what?
2 pi.
2 pi, right? Because what does this represent right?
The portion
The
of
first,
circle.
exactly. This represents the area of the,
And that represents the percentage of the circle.
and this represents the percentage of the circle you want. What cancels really nicely?
Pi.
The pi cancels. The pi cancels, and what are you left with? 1 over 2 r squared theta. Yeah, we're pretty good with that, right? Okay, so if you wanted one slice here, if you wanted one sector, if you wanted this sector, and it's hard to draw this, can you see the blue I'm drawing in there? I can never tell sometimes. Can you see that blue? Okay, good. So if you wanted just this area right here, how would you go about finding just that area right there? Yeah, but what do you have to take away?
The middle.
The littler one, right? So you have the big one and the littler one. You're taking away. This is the same thing, like if we had two functions in terms of y, you have the upper function minus the lower function. We love it when it's equal to the x-axis because what are we subtracting? 0. Are we always going to be subtracting that? No. This can be bumpy and strange and all sorts of warpness. So what does this translate to in terms of a general form? Yes, go ahead. Have fun, Jay. We end up with what? 8 cosine theta plus 16 sine squared theta minus cosine theta plus squared theta. And now we have to integrate with respect to theta. Can we simplify that a little bit first? Oh, so what is it? 7 cosine theta? Did I do something wrong? I think it's okay.
Oh, I remember something.
Plus 15. Is this correct? Is it 15? D theta? Okay, so now we get to the fun part. Now we're finally to the fun part. Can someone tell me what the fun... Danny, what's fun about this part?
Sine squared theta.
Yeah, we have to integrate, and we love integrating, but can you tell me what specific thing are we going to have fun, quote-unquote, integrating?
Oh, substitution.
Which thing do we need to integrate that's fun?
Sine squared.
Yeah. That should be a warning bell at this point, at least. At this point.
There's a formula.
Maybe it's not. What should I do first?
Run away.
Run away? Oh, come on.
Integrate by parts once.
Okay, give me a step. That's like saying, to get to Boston, you need to drive a car when I don't know what a car is or how to drive. So tell me, what's the first thing I need to do? Okay, let's combine forces like we're Voltron and make the super Voltron, okay? All we're trying to do now is integrate sine squared. How do we do it?
Set up U and V.
I got it. We need to drive the car. So what is u going to be? What's v going to be? How are we going to do this?
We set u equals to
0 to pi of theta times... We'll put the 2 out front here, right? Is that okay? Oh, no. Bad, Mr. Seaman. Bad. Don't give away the punchline. So this is where I usually get to. I remember doing this out the first time a couple years ago. I hadn't done it in a while. I was like, oh, man. Nasty, stupid. And then all of a sudden, what do you notice?
that equals to sine equals theta.
Yeah, you end up with negative 0 to pi of theta times what? Sine 2 theta d theta. This right here is equal to sine 2 theta. This actually came up today in AB calculus. The same exact thing came up, except we went in the other direction. Is this now doable? Sort of. Is it better? It's better, but okay, so what do we do now? Well, yes, tabular, but what's the better way of saying that? Yes, I understand tabular.
By part. By part.
We have to do it by parts?
Yeah.
Tabular is by part.
Yeah, it's by parts. I just don't call it that. It's fine. That's fine. Let me pause this again.